Hi and welcome to Elaboration 6, part 2 of Elaboration 6, derivatives. So what I'm going to do here is I'm going to consider the following equations. So I'm going to consider this equation here, y equals to 12x power to 3 minus 5x power up to 2 plus 3. And then I'm going to define an x vector from minus 5 to plus 5 and use it together with diff function to approximate the derivative of y with respect to x. And then I'm gonna analytically find the derivative of y with respect to x, which is dx divided by dy equals to y prime equals to 36x power to 2 minus 10x. So I'm gonna do that right away. So I'm gonna create this x vector here from minus 5 to plus 5. I'm gonna do it with linspace as the part 1 of the elaboration to make it more quick, to make it quicker. Minus 5, 5 and 11 numbers between them. 11 numbers from minus 5 to plus 5, and the function is y equals to 12 times x powered up to 3 minus 5 times x powered to 2 plus 3. I'm just gonna check if it's right. Yeah, I remembered it correctly. That's good. So so the y diff, the diff function, I will use it to create the derivative. Y diff equals to the diff of y, so the difference of y in the different x values that we put in this equation here. So equals to diff of y and then the derivative I'm going to call the derivative of y derivative of y, which is equal to 36 times x. We can do it directly from here, like 3 times 12x times x powered up to 2 minus 10x, so minus 10 times x, I mean. So that, you can see that right away. Instead of going back and looking into the elaboration PDF, minus 10 times x, and then I'm gonna plot the x and y. And what I'm gonna do now is I'm gonna evaluate the function using the x vector I previously defined. What is the difference in my results? So I'm gonna use the inter p1 function to fill a table which one column is representing x from minus 10.5 to 10 plus 5 with a step of 1 in between. So that means from minus 10.5, as you can see here, to minus 9.5 to minus 8.5, all the way up to plus 10.5. So I'm gonna do that. I'm gonna call this one for x2 then. Is this column x2 equals to minus 10.5 and colon 10.5. So we get one step in between each higher step. So it increases with one number for each step that goes up. And then I'm gonna do the y2, which is equal to the same. It's the same as y, but of course with this x values, then with the x2 values, so not with the x values. 12 times x. I can copy it from here, paste it in, and then I need to change for the x2 here and the x2 here. Yes, and then I'm gonna plot this as well. The x2, y2. So the other column represents the error between the real value of y and the interpolation done by using inter p1 functions try with linear spline and p-chip. So I'm gonna create another x here, x3, I'll call it x3, with the values minus 8, from minus 8 to 8, and I will have 22 numbers. Sorry, I forgot the lean space here. So it's 22 numbers between minus 8 and 8. I get, and the y3, I'll call this for y3, is the inter p1 function that I'll use in it. Inter p1 for the So the inter p1 is the x2, y2, x3 in this case, and I'll use linear here. Linear so now I use the inter p1 function to fill a table which one is representing x from minus 10.5 to plus 10.5, and I'm gonna create the table now after I've used the inter p1 function. So I'm gonna call it for, sorry, table 1 equals table transpose. So I'm going to transpose here the x2. So when the table is being created, it shows the numbers as well. Let's see in the table, not only that is x2. This is the values of x2, which should be visible there in the table. And I will transpose the y2 and I'll transpose the y3, the y3. So what I'm gonna do next, the operation says that I'm gonna use the inter p1 function in the extrapolation mode this time. I'm gonna build a table similar to the one of previous exercise, same values and also pure extrapolation values, from minus plus 10 to minus plus 500, and the column should represent the errors for each x when using the inter p1 function. So I'm gonna have the same values for the x2. So what I will use here is x2 again in the y function again, but this y function will be called for y4. So create x values here with I will create x values from minus 100 to 100. Linspace minus 100 to 100 and 22 numbers from minus 100 to 100. And the y4 here is the same again as this, so and I'm gonna plot this as well, this figure, x2 y4, x2 y4, and this time I will use the inter p1 function, it says in the elaboration, in the extrapolation mode. So I'm gonna do that by calling a new inter p1 function. I'll call it for y5 equals inter p1 x2 y4 x4, and I'll have the linear again, and now I will have the extrapolation mode as well. Sorry, I forgot the apostrophes here and here. So extra p. So now I'll create a table 2. It says I will create a table here. This is one of previous exercise. So the values that is different here is the x4 compared to the x2 here. I have from minus 10.5 to 10 plus 10.5. And here I have from minus 100 to 100 in x4. So the table 2 will be table, and then I will transpose again the x2 will transpose the y4 this time, for which is the same as y2, but yeah, to show that it's for this question. And then I will transpose into P1 function in the extrapolation mode. Y5. So that's what I've done now. So the last task for part 2 is, for the equation given, I will find out different polynomials from degree 1 to 6 with function polyfit. So I use these polynomials to add to the previous table column where I indicate the error given by them for each value of x. So what I will do here is I will use polyfit, and I will find out different polynomials from degree 1 to 6 for the equation that we have. I will call it Z1. Polyfit x2, y2, and of degree 1. So we'll do six of this, because we'll do from degree 1 to 6. So this is the first degree. As you can see, I put a 1 here. This is the degree. I will create another one, Z2, which is equal to, again, polyfit x2, y2, and 2 this time because it's degree 2. So what I simply can do here is to copy that and paste it in all the time and change only the degree and the z number, of course. So this is the 3, and this would be degree number 3. So this is Z4, degree number 4. So, and again Z5, and this is degree 5, and this is the last one, Z6, which is degree number 6. So now we'll read again what is to do. I will use the polynomials to add to the previous table column indicate. So I will add this polynomials to the previous table column where I indicate the error given by them for each value of x. So I'll simply create the same table, but I will put in the polyval, the fitting for. I will use polyval as well here. So I will call F1 for the polyval of Z1, X2, and I will create 6 different tables. I can create one as well, but I choose to create 6 different tables here to show that I've understood it right. Equals to table, and in the table I will transpose again the x2, the y2 as the before tables, the x2 here, the y2, Then I will transpose the F1, transpose the F1, which is this one here, F1 for polyvol, Z1 x2. So it's bring us the polynomial and the x2 values here, over here. The polynomial of degree 1 and the x2 values. So that is what F1 is. And I will also, this is the fitting in the table, and I will also transpose the error, which I will call for y2 minus f1. So now I'll create the same thing for the other 5 tables that I will create. So I can took it away by mistake, but I will do it again here. Polyvol Z1 and the x2 and the table 3 will be equal to table, and then transpose x2 to transpose y2, then transpose the f1 fitting for the first degree of the polynomials, and I'll transpose the error, which I will call -2, which I will call for y2 minus f1, and then I will copy this and paste it in again for the 6 other tables, but this will be the f2, of course. This will be the z2, and this will be the f2, and here also the f2. Now we can go to the next table. This will be the f3. This is z3, f3 y2 minus f3. This is the f4. This is z5, and this is the f5. And this is also f5. And the last one here is the f6, 6. This is the last table, and we have f6 here, y2 minus f6. So I think I'm done here. Yes, I'm done. So I'm gonna run it now. I'm gonna call it for lab 6 for2.m. So it's giving me unrecognized function or variable transpose. Oh, transpose. So I did something. I missed an S here somewhere. It's in line 25. Yeah, over there. I missed an S, so I will run this again. S, and it's giving me everything, as you can see here. You can see in the beginning. Beginning of it. If we look at the command window here, this is the x values from -5 to 5, 11 numbers. As you can see, this is the y values when we put in the y value of the function value when we put in the different x values. So we have 11 different values, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yes, and the y diff, this is the difference in the y when we put in different numbers, like from -1622 to -845. And then the difference between 845 and 366 as well. And then the difference between this and this and this and this and this and this, between this and this. So as you can see here, this is the difference between each two, like this two and then this two. And this is the derivative of y. When we put in the x values in the derivative of y, it's 11 values as well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And this is the x2 from -10.5 to 10.5. And as we can see, it increased as it said in the lab, as it wanted in the lab, with one number with each increase step from -10.5 to -9.5. And the y2 here is given as well when we use the x2 values in the same function. Yeah, this is 22 different numbers, or so I don't know, it's more than 22 I guess. The x3, the lean space -8 to 8, it's 22 numbers in between there, so it got us this 22 numbers in the x3. Yes, and the y3 with the inter p1 function, x2, y2, x3, linear, and then as we can see we have 1 times 10 powered up to 3 times each of these values. This is the different value for the inter p1 function, and then we got the table for that. I transposed the x2, the y2 and the y3. So the table is here. You can see in the first column, as it said here, representing the x from -10 to +10, -10.5 to +10.5, and the other columns represent the error between the real value and the interpolation done by using the inter p1 function. So This is the x values from minus 10.5 to 10 plus 10.5. We can display all the 22 rows here. The second column is the error between the real value of y, as you can see, from minus 14,440 until 13,343, and the last column is an interpolation done by using the interp1 function. So using this interp1 function, this is the interpolation that we got in the third column from minus 6,434.2 to 5,897.8. And if we go, we need to run it all again, because I ran it in the beginning only for the first part, which I did wrong, which was wrong from me. Anyway, we went through this, so this is the x4. As we can see here, the lean space from minus 100 to 100 with 22 numbers in between. This is what we have here, 22 numbers from minus 100 to 100. And this is the y4, using the x2 and not the x4, because it said here in the test that we're gonna use a table similar to the one of previous exercise, same values and also pure extrapolation values. So this is the pure extrapolation values, and this is the same values, the x2. This is this x2 values, minus 10.5 to plus 10.5, and then the plot. Look at the plot here. For the minus 1.5 to 1.5 times 10 powered up to 4. So 1,500 here, 15,000 until minus 15,000. So this is the plot for the x2 and y2. And next here is I plotted also x2 and y4, which is the same. That's why I got only one plot here, because it's the same result using the same x values here. y4 is equal to y2, so we gave us the same plot, because it's also the x2 values in both plots, in both of the plots. So, and the y5 interp1 function of 1,5 in the with the extrapolation mode. In the extrapolation mode gave us these values here, 1 times 10 powered up to 5 times all these values. And it's linear as well. And the table 2, I transposed exactly the same, but here instead of y4 is the same as y2, because we have x2 in both of them as the x values, the function, and then we have here I transpose y3 and here transpose to y5. So we have the table here. We can display all the 22 rows. This is the x values again from minus 10.5 to plus 10.5. And this is the y2 values again, which is as the y4 values, which is the same as the y2 values. And this is the error, but for y5 then. Using the x4 in here instead of the x3 that we used in here. So this is the difference in the two tables. And then I used the polyfit, and then for the equation given, I used the polyfit function to find out the different polynomials from degree 1 to 6. Different polynomials from degree 1 to 6. I did a name for each degree, and in the polyfit I put x2, y2, and 1. So as you can see here, the Z1 gave us 867 minus 198.2500, and the Z2 gave us minus 5, 867 and 3, the Z3, and so on, as you can see. And as we can see here, it's only one number, 867 minus 198.25. This is the first degree. The second degree is 3 numbers. The third degree is 4 numbers. The fourth degree is 5 numbers. The fifth degree is 6 numbers. And the sixth degree of the polyfit function to find out the polynomial of degree 6 is giving us 7 numbers from minus 0 to 3. And the F1 here gave us 1 times 10 powered up to 3 times all these numbers here using polyvol Z2, X2, and the same with the others. F1, the same with the others, F2, but F1 gave us F1 gave us the table. F1 is the fitting in the function polyfit. So and then the table I created a table after each F, and as we can see, this is the table for F1. You can display all the 22 rows here. It's the same, the X2 values, the Y2, Y4 values, the Y2, Y4 again, or the F3 values, F1 values, and the error values in the last column, in the fourth column. And sorry, here is the table for F1. And so on and so on, the table for f6, the table for f5, the table for f4, the table for f3, table for f2. Yeah, so I've done that, and thank you, and in the next video I will go through the last part of elaboration 6.